Hello everyone, I hope you all are fit and fine. Once again, I welcome you all in this new video of environmental economics, wherein we will cover the theory of optimal utilization of exhaustible resources or non-renewable resources. See, before understanding the theory, the very first thing which you should know is the meaning of exhaustible resources. These are the resources which are in limited quantity. Moreover, these are the resources which can be used only once. That is, once you use them, they cannot be reused. That is why they are called exhaustible resources. Moreover, these are the resources which takes many years. They take many years, particularly they take millions of years to reproduce. So these are some of the features and characteristics of exhaustible resources that will help us in understanding the theory of optimal utilization of exhaustible resources. See friends, in the standard theory of microeconomics, you must have studied that a producer is in equilibrium at a point wherein he is equating his marginal cost with the marginal revenue. This is the condition for optimization for a producer. All right, and this is the case of an ordinary good. In case of an ordinary good, the condition for optimization for a producer is marginal cost should be equal the marginal revenue. All right, so this is the case, and wherein price equals to the marginal cost. As we know that a price taking firm, for a price taking firm, price equals to the marginal revenue. All right, so this is the case. However, if price is greater than the marginal cost, then what would happen? The producer will increase his production. We all know that in the standard theory, we all have studied this thing. So if the price is more than the marginal cost, then the producer can increase his production so as to earn more profit. This is the case of an ordinary good, wherein the production can be increased when price is more than the marginal cost. However, in case of exhaustible resource or non-renewable resource, if this is the case, that is, price is greater than the marginal cost, then the producer cannot increase his production. He cannot increase his production. And why is it so? Because the available quantity of exhaustible resource is limited. And these are the resources which cannot be reproduced like ordinary goods. So we have to modify the standard theory a little bit so that we can understand the theory of optimal utilization of exhaustible resource. So let's understand the theory. Okay, so in the case of an ordinary good, we have price equals the marginal cost. And if the price is greater than the marginal cost, then the production can be increased. All right. However, in case of exhaustible resource, we have to modify this overall condition, wherein price will remain the same. However, we have to make certain changes to the marginal cost. Friends, see, in case of exhaustible resource, over here we are assuming an exhaustible resource which is crude oil. All right, so in case of an exhaustible resource, the producer is having two choices in front of him. The producer is having two choices in front of him. He can extract the resource in the present time period or current time period. All right, the first case is he can extract the resource in the present time period, or he can extract the resource at some date in the future. So the two options which are available to the producer are, the first one is he can extract the resource in the present time period, or he can extract the resource at some date in the future. All right. So if he decides to extract the resource today, that is in the present time period, then he is foregoing a return which he could have earned if the resource was instead being extracted and sold in the future. So you see, in case of exhaustible resource, there is an opportunity cost associated with the extraction of the resource. I'm repeating this thing again, and this is really very important to understand this theory. In case of exhaustible resource, there is an opportunity cost associated. And what is this cost? Opportunity cost is the return which the extractor is foregoing by deciding to extract the resource today and not in the future. So let's understand this through an example. Suppose the price of 1 barrel of crude oil is worth $100. The price of 1 barrel of crude oil is worth $100, and this is the price in the current time period. So if the extractor extracts 1 barrel worth of crude oil from earth and then he sells that crude oil, then how much he will earn? He will earn $100. If the price of 1 barrel of crude oil is worth $150 in the future, all right, if the price is $150 in the future and the extractor decides to extract the resource today, he is making a decision of extracting the resource today and not in the future, which means he is foregoing a return of worth $50. And this $50 is nothing but the opportunity cost. And in case of optimization, in case of exhaustible resources, we call this opportunity cost the user cost. We call this opportunity cost the user cost. I hope you all are understanding what I'm trying to say. In present time period, price of crude oil of 1 barrel is $100. And for example, if it in the future, if this price increases to $150, and if the extractor decides to extract this 1 barrel worth of crude oil in the present time period, then he is foregoing a return of $50, which is the opportunity cost, and this opportunity cost is the user cost. Friends, understand one thing, that the available quantity of exhaustible resource is limited. So if we decide to extract 1 unit today, then we have 1 less unit available in the future. And that is why opportunity cost is involved in the case of optimization of exhaustible resources. So let's understand this through an example. One more example I'm giving you. And through this example, we will derive the equation, the fundamental equation for optimization. So for simplicity, we are assuming only 2 time periods, time period 0 and time period 1, wherein time period 0 is the current time period and time period 1 is the time period in the future. So there are 2 time periods, time period 0 and time period 1. The price in time period 0 is P0. The price in time period 1 is P1. And the cost basically the marginal cost or the cost of extracting the resource, which is C. And this cost, we are assuming that this cost is constant in both the time periods. So there are 2 time periods, time period 0, time period 1. The price in time period 0 is P0 and the price in time period 1 is P1, and the cost, that is the marginal cost of extraction, this is basically MEC, that is the marginal cost of extraction. We are assuming this cost to be constant. So the return which could be earned in the present time period is price minus the cost. And the return which could be earned in the future is P0 minus C. So the return which could be earned in the present time period is P0 minus C, and the return which could be earned in the future is P1 minus C. So if the producer decides to extract 1 unit today and sell it, then the overall earning of the producer would be what he is earning in the present time period minus what he is earning in the future. Because he is foregoing this return by deciding to extract the unit today itself and not in the future. However, P naught minus C is something which we are going to earn in the future. We have to arrive at the present value of this P1 minus C. So P1 minus C, if we divide this by 1 plus R, where R is the discount rate, then this gives us the present value of future return. Then this thing gives us the present value of our future return. So by deciding to extract 1 unit today, what would be the overall return of the extractor? The overall return of the extractor would be P naught minus C minus the return which he is foregoing. This is what the producer or the extractor would earn by deciding to extract 1 unit today and sell it in the present time period. If P naught minus C is greater than P1 minus C divided by 1 plus R, then the extractor would extract more resource in the present time period. Then more resource is extracted in present time period. Why is it so? Because this is what he is earning in the present time period, and this is what he would earn in the future. If what he would earn in the present is more than what he would earn in the future, then it is beneficial or it is profitable for the extractor to extract more resource today itself, that is in the present time period. If this case would have been P naught minus C1 is less than P1 minus C divided by 1 plus R, then he would extract more resource in the future. And why is it so? Because what he would earn in the future, that is P1 minus C divided by 1 plus R, would be more than what he will earn in the present time period. I hope this is clear to you all. Now let's move further, and we have to make certain adjustments to this equation. To this equation, we have to make certain adjustments. See, just now we understood that what would be the case if P naught minus C is greater than P1 minus C divided by 1 plus R, or what would be the case if P naught minus C is less than P1 minus C 1 plus R. For optimization, optimization requires that P naught minus C should be equal to P1 minus C divided by 1 plus R. That is, the extractor should be indifferent. It should be indifferent as to extract the resource today or at some date in the future. So we have P naught minus C should be equals to P1 minus C divided by 1 plus R. Making certain adjustment to this equation, we have P naught equals to C plus P1 minus C divided by 1 plus R. We are taking this minus C on the right hand side. So what we get here is the first fundamental condition for optimization of exhaustible resource. First fundamental condition for optimization of exhaustible resource. Now let us understand this fundamental equation. We have P naught. P naught is the price. Price equals to C. What is C? C is the extraction cost, or we can take it as marginal extraction cost, plus P1 minus C divided by 1 plus R. This is your opportunity cost or marginal user cost. We studied before that what is the user cost. The user cost is the highest return which the extractor is foregoing by deciding to extract and sell 1 unit of resource today itself rather than in the future. So this is your marginal extraction cost, and this is your marginal user cost, or we can simply say it is the user cost. And price should be equals to the augmented marginal cost, wherein augmented marginal cost is nothing but marginal extraction cost plus marginal user cost. So you see, for a producer, the optimization requires that price should be equal to the marginal cost. The same thing is here in case of exhaustible resource as well, but we are making certain adjustment in case of marginal cost. Marginal cost becomes augmented marginal cost in case of exhaustible resource. And this augmented marginal cost comprises of marginal extraction cost as well as marginal user cost, wherein extraction cost is simply the cost which the extractor is going to incur when he extract the resource from the ground, whereas the user cost is the return which the extractor is foregoing by deciding to extract the resource today itself. I hope this thing is clear to you all. The very first fundamental condition of optimization is price should be equal to the extraction cost plus the user cost. Now let's move on further. So we have P naught equals C plus P1 minus C divided by 1 plus R. Now we have to make further certain adjustments to this equation, wherein we will get 1 plus R equals P1 minus C divided by P0 minus C. And this is the second fundamental equation. The second fundamental equation for optimal utilization of exhaustible resource. And this fundamental equation is called Hotling's rule. This is really very important for you. The second fundamental equation is called the Hotling's rule. And what does the Hotling rules tells you? It says that at the optimal extraction path, I'm repeating this thing once again, please listen to this carefully. The Hotling rule states that at the optimal extraction path, just let me write this thing. So we have 1 plus R equals P1 minus C divided by P0 minus C. This is the second fundamental equation, which is the Hotling's rule. The Hotling rule states that at the optimal extraction path, and at the optimal extraction path, what exactly is happening? P0 minus C equals P1 minus C divided by 1 plus R. You can recollect this equation. Just now we did this. At the optimal extraction path, where the extractor is indifferent as to extract the resource today or at some date in the future, the price of the resource net of the extraction cost, that is the user cost, has to rise at a rate which is equal to the rate of discount. Again, I am repeating this thing. At the optimal extraction path, where the extractor is indifferent as to extract the resource today or at some date in the future. See, at the optimal extraction path, what is happening? P0 minus C equals P1 minus C divided by 1 plus R. This is what he is earning in the present time period, and this is what he would earn in the future. So at optimal extraction path, what is happening? The extractor is indifferent. The price of the resource net of the extraction cost. Just now we saw this. That price should be equals the extraction cost plus the user cost. So price minus the extraction cost equals the user cost. So the price of the resource net of the extraction cost, that is the user cost, has to rise at a rate which is equal to the rate of discount. The user cost should rise at a rate which is equal to the rate of discount. Let's understand this thing through an example. All right, for example, if the interest rate is 10% and the user cost is rupees 50. Friends, please understand this thing carefully. If the rate of interest is 10% and the user cost is rupees 50, then in the next time period, the user cost should become rupees 55. If you see, 10% of 50 is 5. 50 plus 5 is 55. So in the next time period, the user cost should become at least 55. So as to satisfy the Hotlink's rule. But if it in case the user cost increases by less than 10%, for example, if the user cost increases by just 5%, then the user cost in the next time period would become 52.5 rupees. If the user cost increases by less than 10%, then in the next time period, the user cost would become rupees 52.5. Then in this case, it would pay the extractor to extract more resource today rather than in the future. And why he would extract more resource today? Because after extracting the resource, he is going to sell them, and the money that he will get from selling the resource could be invested in interest yielding bonds, wherein he would get a return of 10%. I hope this thing is clear to you. Once again, I'm repeating this thing. If it in case the user cost increases by less than 10% in the next time period, then in the next time period, the user cost would be 52.5. And this 10% is less than the current prevailing rate of interest, which is 10%. So what the extractor would do, he would extract more resource today. And when he would extract more resource today, he is going to earn money by selling the resource, and he can invest that money in interest yielding bonds or assets, wherein he would get a return of at least 10%. Now reverse this case. If, just give me a minute, if the user cost increases by, the user cost, just a second, okay, if the user cost increases by more than 10%, let us assume that in the next time period, the user cost increases by 20%, wherein in the next time period, the user cost will become rupees 60. Then in this case, the extractor would extract less resource today. He would extract less resource today because he knows that the user cost in the next time period would increase by more than 10%. So it would be beneficial for him to extract the resource in the future rather than in the present time period. I hope Hotlink's rule is clear to you. Now let's proceed further and try to understand this optimization of exhaustible resource through the diagram. All right, so again, we are assuming two time periods, time period 0 and 1. This is the current time period, this is the time period in the future. And the overall stock of the exhaustible resource that is available is OS, as can be seen by these two vertical lines. These two vertical lines are representing that the overall stock is a fixed number. From origin to S, we have the fixed stock of exhaustible resource. And on the vertical axis, we are representing price, cost, and revenue. So OS is the overall stock available with us. OQ2 is what is required in the present time period. Present generations require only OQ2 level of resource. OS is the overall stock. OQ2 is what is required in the present time period. If we subtract OQ2 from the overall stock, what we get is Q2S. This is what is required or left for the future generation. Q2S, from Q2 to S, this is represented by Q1, this is represented by Q1 is what is required in the future. I hope this much is clear to you. Now, if we are using the resource till OQ2 level, please understand this thing very carefully. If we are utilizing the resource till OQ2, we are not robbing off any resource from the future generation. When we are utilizing the resource till level Q2, we are not robbing off any resource from the future generation. And that is why you will see that the marginal user cost curve starts from the point Q2. The marginal user cost curve starts from the level Q2. You know what is user cost? User cost is basically the opportunity cost. And what is this opportunity cost? It is the highest, it is a high return which the extractor is foregoing by deciding to extract the resource today itself. All right. So the marginal user cost will start from the level Q2. Whereas if you will see, the marginal extraction cost is starting from the origin itself. This basically tells us that no matter what, we extract the resource in the current time period or in the future, we have to incur the extraction cost. That is, the cost for extracting the resource has to be borne by the extractor no matter what, no matter in which time period he extracts the resource. Let me rub this thing. All right. So we have marginal extraction cost starting from the origin, whereas the marginal user cost starts from the level Q2. And just now we understood the reason for this. We have the augmented marginal cost equals the marginal extraction cost plus marginal user cost. So you will see that the augmented marginal cost curve is a kinked curve. This is your augmented marginal cost curve. It is a kinked curve at this point. Let us say point A. At point A, there is a kink in augmented marginal cost curve. And why is it so? Because till level Q2, the marginal user cost is not there. Because only after Q2 level, we are robbing of the resources from the future generation. If you utilize the resource beyond Q2 level in the present time period, then what is available for the future generation would reduce. All right, so that is why there is a kink at level Q2. So from origin to A, there is a kink. Afterwards, this line, we have the augmented marginal cost curve. I hope till here everything is clear to you. Then we have the marginal revenue curve, which is a downward sloping curve. We all have studied this thing in our standard theory of microeconomics. So the optimization requires that the price should be equal to the augmented marginal cost, which is equal to the marginal extraction cost plus marginal user cost. So at this point, which is E star, we get the optimal level of the resource which is to be extracted, that is Q star, and the optimal price at which this resource should be sold is P star. So the point where marginal revenue cuts the augmented marginal cost curve is E star, and this point gives us the optimal level of resource extraction, which is Q star, and the price at which this resource should be sold is P star. Now let us understand one more thing. What if marginal user cost was not there? Marginal user cost is special in case of exhaustible resources. So what would have been the case if the marginal user cost was not there? Then the price should have been equal to the marginal extraction cost. We have price should be equal to the marginal extraction cost, and it comes at somewhere here, and then the level of resource that would have been extracted would have been Q double star. And you would see that this Q double star is more than the optimal level which we get when we consider the user cost as well. So you would see that when we are not considering the user cost, then the resource is overutilized. Then the resource is overutilized or over depleted by the level Q star, Q double star. So this was all from my side for the theory of optimal utilization of exhaustible resource. I hope I explained the theory very well to you. If in case you have any doubt, then you can comment in the comment section. And if you think that there are certain mistakes which I committed, or there are certain things which can be improved in my lecture, then please do comment. Thank you, friends.